Let's now uncomment sections 22 and 23. They are both related to the removeEntry method. Okay, let's now have a look at what we did from the previous section. If you go to the birthday book over here, let's see what we did for the removeEntry here. Before, we simply just said we call the helper method index of the name, and we say that if the index that's returned is actually less than 0, meaning that the name does not exist, and we simply just don't have to do anything. Otherwise, we have to remove the associated entry for the name. So that's something we left off from the previous section, and we're going to complete it for the current section. Let's go back to the tester over here, and then you can see that this place over here, bb.removeEntry, as the comment tells you, over here, D does not exist. So nothing new for this particular method call. Okay, so we just go to section 23, and now we are removing an entry that has an associated name that exists. So now we have to do something new to it. We got to extend our removeEntry method. Before we code it up in Java, I would like to show you conceptually how that works. I'll show you one possible solution, and you're advised to study that carefully. Okay, that one involves a little bit of sophistication of doing the loop, not nested loop, just a single loop. Okay, let's now have a look at on the notes and see how we can understand, can visualize this particular solution. Okay, so now let's now imagine that we have BB, which is an object of type BirthdayBook. Okay, let's put BirthdayBook, the class name, over here. And let's just look it up to see how many attributes we have in the birthday book. Let's remind ourselves. You can see for birthday book, we got these 3 attributes. Let's not worry about the constant. Maximum capacity is always 10. So we got 2 attributes there. We got entries, which is an array, and we got NOE, which is an integer. Okay, let's now put NOE over here, and we put entries over here. Now, what should be their initial values? You can see that we have only one constructor for birthday book. So this means as soon as after you create a new birthday book, let's say if you say birthday book, BB is assigned to a new object's birthday book, and with no parameter. After this, what do? We execute 2 lines of code over here. We say that, first of all, entries is assigned to be a new entry array with size 10. Okay, that's always the constant. Okay, let's draw that. Initially, it's going to be an array of size 10. Wrong place. It's going to be an array of size 10. So we got indices from 0, 1, 2, 3, 4, 5, all the way to 9. Okay, that's what it does initially. Now, every slot simply just contains null. I just wouldn't write it, but just initially, we store nothing meaningful, just null references for every slot initially. And the NOE is going to be initialized as 0. So I'll put 0 here. So that means NOE is now pointing to over here, and then that means the next entry to be added to the birthday book would just have to be stored in index 0. Okay, of course we have defined the add entry method in the birthday book in the previous section, which you have to make sure you understand before try to understand how we can remove entries. Okay, now for illustration, let's assume we have 5 different entries that has been inserted into the birthday book. Let me just move this line here away so we can have some more space over here. Okay, so now let's do the following. So now let's say we have 5 entries in the birthday book the entries. So we have entry 1. Let me just first of all, let me draw 5 entries. Okay, for simplicity, I'll just say E for entries. And for each entry, remember we have, over here. Okay, so now we have entry over here, and each entry has two attributes. Okay, let's just go back to entry here. You will see that for entry, we got name and we got birthday. Okay, so I just wouldn't worry about the birthday objects. For this purpose, we don't need to know, just the name. We got name, we have entry. Okay, and a second object over here, we have E, and we have name entry. Okay, then we have 3, 4. Okay, let's put 5 over here. So we got 5 entries. Also, we got name, we got entry. Let's say for the name, we just get A, B, C, and then name entry. D, okay, name entry and E. A, B, C, D, E. We got 5 entries over here. Okay, let's say the bb.entries at position 0 is storing the address of this entry. Okay, and similarly we have that number 3, number 4, number 5. So this means currently NOE is actually pointing to position 5, which means we got 5 entries. Okay. At the moment. Okay, let's say we have already done the add entry properly. So we got 5 entries. So now let's consider this line here. Let's say we want to remove the entry. Let's see how we can do that. So we can say bb dot remove entry over here, and then let's pass some existing name. For example, I say C over here. As you can see, the entry with name C is over here. That means we want to remove this entry here. Okay, this is how we can do it. Conceptually, we're going to delete this entry here. Basically, that's what we want to delete. But how do we do that? We do that by removing its link, by removing the link from position 2 to this particular object. So that's what we want to do. Okay, let's see how we can do that. So now, let me ask you this question. After removing this particular object over here, where should position 2 of the entries array point to? Okay, think about the question there. So after removing this object here, where should this index point to? The answer is it should point to the next one in the entry, right? So we are basically shifting the entry at position 3 over here and then to the left by 1 position. So it will be as if we do the following assignments. Okay, I'll write it down here. So now you can think about we have bb dot entries at position 2 because we at position 2 because the entry we would like to remove is at position 2 right now. That one is not going to point to this entry anymore. What we will do is we'll say that one is assigned to bb dot entries 3. Okay, so what does that do? What that does is it is going to say rather than pointing to here, it is going to point to here. Okay, and similarly, we're going to do bb.entries at position 3 is assigned to bb.entries at position 4. Okay, so and then we're going to say this one is not going to point to over here anymore. It is going to point to the next one. Okay, so now we're going to say that one is going to point to over here. Okay, so up to now, I would like to just make the diagram a little bit clearer for you. Okay, so now you can see that this is the new link over here, and this is the new link over here. So now, up to now, we haven't done yet. As you can see, we have some unexpected aliasing over here. You can see now how many references are there that are actually pointing to this particular object. The last object, you can see the last object is at the position. Let me show you here. So you can see this one here used to be, I'll say used to be, right before we do the remove entry, used to be at bb dot entries, and we have NOE minus 1. Remember, this is NOE, right? Because before we remove the entry, we got 5 entries there, so NOE was just 5. And then NOE minus 1 will be this position here, 4. So that's kind of the last entry we have to consider. But we have to consider that a little bit more specially. Okay? So now you can see that this entry here used to be at this NOE minus 1 position. However, we can see that this one here and this one here, they're both pointing to the same object here, but that's not what we want. So what we want to do is, we want to say, I will just write down the step to you. You will say, somehow we're going to run a loop. We can say for integer I is assigned to 0, and then I less than NOE minus 1. So we only go up to and including NOE minus 2, only that. In this case, we only go up to and including this particular position. And then we're going to handle this position here separately, outside the loop. And then I plus plus. So what we'll do inside is what we do over here, right? Over here, like here. Okay. So we'll say entries at position I is assigned to entries at position I plus 1. And after the loop, what we have handled will be 2 and 3. Okay. However, we still have to handle this particular one here. Okay, number 4. So this is NOE minus 1. What should we do? We want to say we don't want to have the aliasing anymore. We want to remove this reference here. Okay. What we can do is we can say entries at NOE minus 1 is simply assigned to null. Okay, so we shouldn't store any reference anymore. Of course, at the same time, we should also say NOE minus minus, which means we're going to move this object, this integer pointer here to the left by 1 position. So that's NOE now. And then NOE should be decremented from 5 to 4. Just decrement by 1. Okay, I hope that's clear. If that is not clear, you should really watch the recording and try to do the illustration alongside with my illustration. So you really want to understand the insight into this solution before you want to code in Java. Coding in Java itself is very easy once you get a conceptual idea clarified. But before that, you really want to spend some time understanding why we're doing this, especially why we are separating the shifting to the left job into 2 steps. So we got step number 1 over here. So this step here, we just go for the general pattern over here. Sorry. So inside the loop, we simply go for entries I is assigned to entries I plus 1. This one is shifting everything to the left by 1 position. But we only do this up to and including NOE minus 1 position, which means we're handling this particular position here, as I said before, which got aliasing. We handle that position in a separate step by saying NOE minus 1 position is assigned to null. One thing to note, you can see that the state condition over here is NOE. I is less than NOE minus 1. So what would be the last value for I before we exit for the loop? It should be NOE minus 2, right? So we handle from 0 up to and including NOE minus 2. And then we handle NOE minus 1 separately. Okay? Okay. Hopefully that's clear. And now you should really rewatch the video if you haven't got it clarified. Okay, let's now go back to our Java code. Now everything else should be straightforward. We just have to convert our ideas conceptually into concrete Java code. Let's now go to BirthdayBook, and let me just put the remove method after the add entry method. Okay, you can say public void remove entry. Oh, actually, I don't need to do that because we already got that method. Okay, at around the end. Okay, over here. So now we have already previously completed the special case where the name does not exist. So now we're going to complete this case where the name does exist. So now let me say this step number 1, as we said in the notes, we say from positions 0 to NOE minus 1. Sorry, MOE minus 2. Shift every position. Oh, one more thing to note. Okay, there's something I forgot to mention in the pad. Okay, I just want to correct that very quickly. Okay, so now you should really notice that we really start from integer 0 over here, right? Because we're shifting everything to the left. So that's why you start with BB.entries. So what's going to be the first iteration? Let's write it down very carefully. The very first iteration is going to look like this. We have entries, right? Initial value is simply 0. So you got entries at position 0 is assigned entries at position 1. Let's see if that's really what we want to do. So you can see when we have entry 0, which is this reference over here, that is not going to point to here anymore, and that is going to point to this position over here. Is this really correct? No, right? Because remember, we are trying to remove the C entry over here. So we shouldn't really always start from 0. Okay? So that's somehow, you can see this is wrong. Okay? So how should we fix it? The way we should fix it is by saying we don't always start with 0. That's the wrong place to start. You can see in the example I gave to you, you can see that I actually started with position 2. Why was position 2? It's because position 2 was the entry that contains the name C. Okay, so what we should really do is by fixing this. So rather than starting from 0, we should have done something like this. Integer index is assigned to index of whatever name n that you're looking for. In this case, it can be C, right? So now we should put index over here. Okay? Notice that if you put 0, it's going to be wrong. Okay, so that's something I want to note. Something I just realized I got it wrong, but I think it's good that I explained this. It's also a common mistake. Okay, from position, so not really 0, I would say index to NOE minus 2. Shift every position to the left by 1 position. Okay. Let's now do step 1. For integer I is assigned to index I less than NOE minus 1 I plus plus. Okay, that's what we do. Step number 1. We'll do step number 2 in just a moment. And then here it should be as easy as you can say, you don't have to say this, but I can say this if I want to. This dot entries at position I is assigned to this dot position I is assigned to this dot entries at position I plus 1. Okay, and step number 2, we have to assign position entries I, actually not I, should be NOE minus 1 to null. Okay, so we can avoid the aliasing problem. So we can say this dot entries at position NOE minus 1. That should be assigned to null. And final step over here, we can say decrements NOE. Because we are removing an entry, of course, after that we should really decrement the value. Over here we can say this dot NOE minus minus. Okay, so these are the 3 steps that we have to follow. Again, you have to know very well why we are putting, first of all, the starting index to be just the index of the name that we are trying to remove. And also why this has to be NOE minus 1. And this has to be NOE minus 1 as well. And why are we doing I and then I plus 1 here? So these are kind of the tricks that you have to understand before you can code up in Java. Okay? Otherwise you get confused. Okay, now we are done with the remove entry here, but let's go back to the tester. Okay, so what we'll do is we'll go to the this number 22 and 23. Okay, so for 22 over there should be no effects because we still have the 3 entries in the book because the name that we wanted to remove was D, and D does not exist. But after removing A from there, you can see A will disappear from the book. So we only get in section 23, we got B and C. Okay, let's try to verify that. If you execute this, that's what you'll see. You can see A, B, C from 22, and you can see B and C from 23. Okay, that's as expected. Okay, so now let's convert this into JUnits before we finish this section here. Okay, but again, the most crucial thing about this section here is not just the Java code itself. It's a little bit second issue. The most critical thing is to understand the illustration on my iPad to really understand why, how you can visualize the scenario before you can code out the solution in Java. Okay, so now let's go to the JUnits, and I'm going to code up these two into the JUnit test. Okay. So now let me go to the test over here. So now it's going to be a little bit long because we're going to build up things together. So it'll be 22 and 23, right? So let's go to 22 to 23. Okay, add test public void test 22. Let's just make sure I follow the naming convention correctly. 22 to 23. Okay. To 23. And then eventually we're going to remove, but before that, let's make sure BB contains really 3 entries over there. Okay, let's try to initialize that. Let me just copy the relevant part. Okay, so this one here, we get 3 entries, A, B, and C. Okay, we have that. Okay, so now we can now convert the print statements into assertions for automation. So now we can say that assert equals, so we need to have the expected string. We got something like this before. Let me just copy that quickly, okay, just to save our time. So I think we got expected somewhere into several lines. Okay, it was not this one here. Let's look for that. Maybe I missed that. Okay, let's find that. Okay, over here. It's for test 16. Okay, let me just get this one here. Okay, and then what we will do is for remove entry D, because D does not exist, so we just get the original birthday book after the removal. Nothing will be done. However, now for 23, okay, this is 22. Okay, so now for 23, what should we do? For 23, we're trying to remove some existing name. We want to remove entry A. After that, what we should get is now the expected string should be changed. So now there should be only 2 entries in the book, and A has been removed. So we only got B and C. Okay, so now that's what we should have. Okay, so now let's execute the test. Okay, so now we have accumulated 19 test cases and all of them pass.